Today we will be taking a look at derivatives of trig functions. And in class, what I'm going to do is give my students a few minutes to just review these trig values of unit circle values. And so if you want to take a look at your notes and try that on your own and then come back, I'm going to go through these, but in case you had problems doing it. But I plan to just let them do this in class, give them a few minutes to do this. It is crucial to know all of our trig values when we're in calculus. So do that, pause this, and come back when you're ready. All right. Sine of 5 pi over 3. It's a pi over 3 angle with sine, so I know it's a square root of 3 over 2. I just need to figure out what quadrant it's in, and if it's positive or negative. 5 pi over 3 is in quadrant 4, where sine is negative, so this will be negative square root of 3 over 2. Tangent of a pi over 3 is square root of 3. In quadrant 3, we keep our positive. Cosine of pi over 4 is square root 2 over 2. In quadrant 2, that's going to be a negative for cosine. Remember, all students take calculus. All are positive in quadrant 1. Only sine is positive in quadrant 2. Only tangent is positive in quadrant 3. Only cosine in quadrant 4. All right, cosecant. Well, remember, every time you see cosecant, think that's 1 over sine. So this is 1 over sine of 5 pi over 6. So if you know sine of 5 pi over 6, all you have to do is flip it to get cosecant. Well, sine of pi over 6 is going to be a half, and in quadrant 2, that'll be a positive 1/2. I flip 1/2 to get cosecant. So that'll be a positive 2. Cotangent of 7 pi over 4. It's the flip of tangent. Pi over 4 for tangent is 1. In quadrant 4, that'll be a negative 1. Flip negative 1, still negative 1. Secant is the flip of cosine. Cosine of pi over 3 is 1/2. In quadrant 3, that'll be a negative 1/2. Flip it, negative 2. Sine of pi over 4 is square root of 2 over 2. In quadrant 3, it'll be a negative square root of 2 over 2. Flip it, negative 2 over square root 2, which, if we rationalize, will be just negative square root 2. So the flip of 2 over square root of 2 is just square root 2. All right, tangent of a pi over 6 is square root 3 over 3. In quadrant 4, that'll be a negative. Cosine of a pi over 6 is square root of 3 over 2. In quadrant 2, that'll be a negative. Cosecant of a pi over 3 will be the flip of sine of pi over 3, so we're flipping square root 3 over 2, so it'll be 2 over square root 3. In quadrant 3, we'll make this a negative. Cotangent of a pi over 3. Well, tangent of a pi over 3 is just square root of 3. The flip of that will be square root 3 over 3. It's the other one. So it's going to be square root 3 over 3. In quadrant 2, where tangent is negative. Okay, again, we're flipping, so cosine of pi over 4 is square root 2 over 2, the flip of which is just square root 2. In quadrant 4 will be a positive square root 2. Sine of a pi over 6 is a half. In quadrant 3, negative 1/2. Tangent of pi over 4 is 1. In quadrant 3, it'll be a positive 1. Cosine of pi over 3 is 1/2. In quadrant 2, that will be a negative. Cosecant of pi over 3 is the flip of sine. Sine of pi over 3 is square root 3 over 2. Flip that, and we're going to have 2 over square root 3. In quadrant 4, that's negative. Cotangent of pi over 6. I think to myself, that's the same as tangent of a pi over 3. So it's just a square root 3. In quadrant 3, cotangent is positive, like tangent. Secant of a pi over 6 is the flip of cosine of pi over 6. That cosine of pi over 6 is square root 3 over 2. Flip it, 2 over square root 3. In quadrant 4, where cosine is positive, so I keep my positive. Okay, for sine of 3 pi over 2, this is one of the axes, I think of the graph of sine. Just one curve, one period. Sine of 3 pi over 2 is a negative 1. Yes. Okay. Tangent of 3 pi over 2. I think of the graph of tangent. Tangent has these asymptotes at all the pi over 2's. Negative pi over 2, positive pi over 2, 3 pi over 2, etc. And then each curve looks like this. But at all of the pi over 2's, tangent has an asymptote. So tangent of 3 pi over 2 does not exist because there's an asymptote there. Cosine of pi. I think of the graph of cosine. The graph of cosine for one period does that. At pi, we're halfway to 2 pi. At pi, cosine is a negative 1. So this is negative 1. Cosecant of 0 is 1 over sine of 0. Sine of 0 is 0. 1 over 0 is undefined. This does not exist because there's an asymptote there. Cotangent of pi over 2. Okay, cotangent of pi over 2. Well, at cotangent, I think of the graph of cotangent. Cotangent has asymptotes on 0, pi, 2 pi, all of those. And the graph does this. Each little arm does that. So cotangent at pi over 2 is 0. Remember that I need you to know the basic graphs of sine, cosine, tangent, and cotangent. And those are really I want you to know the basic graphs of all of them, but those are the big ones to know, especially sine, cosine, and tangent. All right, secant of pi over 2. That is 1 over cosine of pi over 2. Cosine of pi over 2, cosine of pi over 2 is 0. So this is 1 over 0. That is another does not exist because of an asymptote. Okay, so a little quick review of our trig unit circle values. Now, we're going to do, in class we'll do this exploratory calculator activity. Grab your calculator. I'm going to grab my calculator. Put it in radian mode. Go to your mode. Make sure that you are in radian mode. Stay in function mode and radian mode. And set your window like it says here. So for our x-min, negative 2 pi. X-max, positive 2 pi. Scale, let's make that pi over 2. For our y-min, make it a negative 1.5. Y-max, a positive 1.5. And for the scale, let's make it a 0.5. All right, and for y1, let's put in sine of x. And we can graph that, and we recognize that that is one period of sine of x. And I'm going to leave that in there. That's sine x. not 1 period, 2 periods of sine x. Okay, from negative 2 pi to positive 2 pi. All right, in for y2, I'm going to put the derivative of sine x. Our calculators have this ability to graph. So the derivative function is under math. So if you'll go to math, and see how there's an arrow here? That means there's more down below. If you go to number 8, it says n deriv. That means numerical derivative. Press enter on that, and you see the notation. D, and then you get to fill in what you want to take the derivative with respect to. We're going to take it with respect to x, and here you're going to put sine of x. And since we want the graph, we want to just put an x there, and that will graph the derivative of sine x for us. Okay? So the way your calculator graphs, it does everything numerically. So it starts at that x value. It starts at the furthest left x value that is in your window, and it computes that. All right? Remember, our window looks like this. So it'll start at negative 2 pi, compute the derivative, and then it goes to the next x value, which in this case is 0.133 blah 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 away from negative 2 pi, computes that derivative, graphs it, goes to the next x, computes the derivative, graphs it, goes to the next x, computes the derivative, graphs it. That's what this will do if you put an x there. It forces the calculator to graph the derivative of sine x. Okay? All right, so now I'm going to graph, and here comes the derivative of sine x. It takes a little time because it is doing all of that work. So my question to you is, what did it just graph? Let's get rid of sine x here. It'll graph it again. My question is, what curve is this? What is this the curve of? What is the equation of that curve? And that is the graph of cosine x. Let's confirm that by graphing cosine x down below. And you're not going to see anything because it is graphing right on top of what was already there. So that is the graph of cosine x. I can turn this off and confirm that. And it sure is. That is the graph of cosine x. So what did we find out? We found out that the derivative of sine x is cosine x. Now we're going to repeat our exploration for cosine x. So in for, I think I'm just going to clear out y1. In for y2, I'm going to clear out y3 as well. In for y2, I'm going to put the derivative of, instead of sine, I'm going to make that cosine. Everything else will remain the same. So let's graph this and see if we recognize the graph. It's taken a little time because it is graphing all of those derivatives, plotting every derivative that 0.133 unit away from the next. Okay, what is that the graph of? It looks a little bit like sine because it's going through 0 and pi and 2 pi, and those are the x-intercepts. Okay, but it's not exactly sine because remember sine of x looks like this. So what is that the graph of? Well, that is the graph of negative sine x. If I graph the graph of negative sine x, there it is. Okay? And I can see it's still graphing because now it's graphing the derivative on top, the derivative of cosine x on top of that. So this is, we found out that the derivative of cosine x is not sine x, it is negative sine x. Okay? So that's just a little graphical exploration of why the derivative of sine is cosine and the derivative of cosine is negative sine. The derivatives of the remaining trig functions would be harder to see that way. Okay? So instead, I'm just going to give these to you. I'm not going to prove them to you, but I'm going to give those to you. There are proofs of these, but they take a little time to derive. So I'm just going to give them to you. The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. The derivative of tangent of x is secant squared of x. It's different, huh? Remember, tangent and secant are buds. They like to go together. They like to hang out together. Okay? Now, if I know that the derivative of tangent is secant squared of x, I can get the derivative of cotangent because it will resemble the same format of the one for tangent. The only difference is you put a negative in front of it. So there's going to be a negative. And instead of secant, secant is tangent's bud. Okay? The bud of cotangent is cosecant. So this will be cosecant squared of x, negative. Okay? All right, the derivative of secant. Well, the derivative of secant, you can expect there to be a tangent in it. And there is. There is a tangent in it. However, there's also a secant. So the derivative of secant of x is secant of x times tangent of x. That's the derivative. I like to say secant, yes, secant is friends with tangent, but secant is very self-centered and it likes to come first. So secant tangent. Okay? Of course we could switch those, but then my story wouldn't make as much sense. Okay? Alright, if I know that is the derivative of secant, I can get the derivative of cosecant. It's going to be negative, and instead of secant, we'll have a cosecant. Instead of tangent, we'll have a cotangent. Alright? You need to memorize these. Make yourself little flashcards, hang it on your bathroom mirror, memorize them, and keep memorizing them throughout calculus. Know these. Alright? Okay, let's see how we can use these in some examples. Alright, if y is equal to 2 sine x, then what is dy dx? So if I come in here to my y and I take the derivative of both sides with respect to x, since I want dy dx, I'm taking the derivative of both sides with respect to x. I will have dy dx is equal to, alright, this 2 that's out in front is just being multiplied by the derivative of sine x. So I just leave the 2. And then I multiply by the derivative of sine, which is cosine. Don't forget your x. Okay? If you like, you can put parentheses around the x, but they are not required. They are implied if they're not there. Just like this is implied to be a parentheses around that x. So you can keep the parentheses or not. It doesn't matter. They are implied to be there though. Alright, if g is 17 tangent x, and we want g prime of x, we will come in and take the derivative of both sides with respect to x, and we will get g prime of x is equal to, alright, the 17 times the derivative of tangent x. The derivative of tangent is secant squared. Don't forget your x. It makes no sense without the x. Alright, next we have this. The first thing I need to do is write this so that we have a coefficient of cosine. So I'm going to rewrite f of x, make it a negative 1/6 cosine x. Change this to be a coefficient. And now I'm going to take the derivative of both sides with respect to x. F prime of x is equal to, okay, the negative 1/6 is just being multiplied by the derivative of cosine x. Well, the derivative of cosine x is negative sine x. So this will be positive 1/6 sine x. Put parentheses around the x if you like, right? Okay, for number 4, I'm going to rewrite y. I'm going to leave secant alone. I'm going to leave cosecant alone. This I'm going to rewrite as negative 1/3 cotangent of x. Okay, come in, take the derivative of both sides with respect to x. dy dx is equal to the derivative of secant is secant x tangent x. Don't forget your x's. The derivative of cosecant is going to be negative. Okay, and the way I think of it is the derivative of secant is secant tangent. So the derivative of cosecant is negative cosecant cotangent. Don't forget your x's. Okay, minus 1/3 times the derivative of cotangent x. The derivative of cotangent is like the derivative of tangent, but negative, and instead of the secant, it'll have a cosecant. So the derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. Don't forget your x. So I can rewrite this as, back here at the back, a plus 1/3 cosecant squared x. Okay, what is the instantaneous rate of change? That's another word for derivative of f of x is equal to cosine x minus tangent x with respect to x at the point when x is pi over 3. So we're going to find the derivative and then plug in pi over 3 for x. So I'm going to write my f. We're going to take the derivative of both sides with respect to x. F prime of x will be the derivative of cosine is negative sine. Don't forget your x. The derivative of tangent is positive secant squared x. But I do have that minus that was in my f equation, so it'll be minus secant squared x. Now we're going to plug in pi over 3 for x. So f prime at pi over 3 will be negative sine of pi over 3. Sine of pi over 3 is square root 3 over 2 minus secant squared of pi over 3. That will be 1 over cosine squared of pi over 3, I'm going to write that like this. 1 over cosine of pi over 3 squared, right? Okay, cosine of pi over 3 is a half. 1 over a half is the flip of a half, and that is 2. So this is negative square root of 3 over 2 minus 4. And there's nothing wrong with leaving it like that. Okay. If they wanted to get a common denominator, we could. As a common denominator, that would be square root of 3 minus 8 all over 2, because 8 over 2 is 4. All right. Number 6. Find the slope of the line tangent, that's derivative. Another meaning of derivative. To the graph of this when x is pi over 6. So first I am going to rewrite y as having coefficients rather than those divisors of those numbers. Okay, now I'm going to take the derivative of both sides with respect to x. We have dy dx is equal to 1/4. The derivative of sine is cosine. Don't forget your x. Plus 1/2. The derivative of cotangent is negative cosecant squared x. Okay. I know I'm going to have to plug in, but I'm going to help myself by changing this to a minus 1/2. Cosecant squared is 1 over sine squared, so I'm going to write that like that. Okay. So now, when I plug in, I'm plugging in pi over 6. So this is read dy dx at x equals pi over 6 is equal to 1/4 times cosine of pi over 6 is square root 3 over 2 minus 1/2. Okay, sine of pi over 6 is a half. The flip of a half is 2. So this is square root 3 over 8 minus 4 over 2. Nothing wrong with that. Okay? All right, number 8. Here's f. Find f prime at pi over 6. Very straightforward. I'm going to take f and take the derivative with respect to x of both sides. What I do to one side, I do to the other. That's why I'm writing this every time. F prime of x is equal to, all right, 6 times the derivative of secant x, which is secant x tangent x. And now I plug in pi over 6 for x. All right, secant of pi over 6 is 1 over cosine of pi over 6. So it's the flip of cosine of pi over 6. Well, cosine of pi over 6 is square root 3 over 2, so the flip of that will be 2 over square root 3. Tangent of pi over 6 is square root 3 over 3, and we can reduce that. The 3's reduce out. 3 goes into 6 twice. 2 times 2 is 4. That would be the multiple choice answer. All right, our last little example. We want to find g prime at pi over 2 given this equation for g. So I'm going to write down g. I don't have to manipulate it. There's nothing to change. I'm going to take the derivative of both sides with respect to x. So g prime of x would be the derivative of sine x minus the derivative of cosine x. The derivative of cosine x is a negative sine x, so that will change this to a plus. oops, I wrote that wrong. Hopefully I said it right. The derivative of sine x is cosine x. The derivative of cosine x is a negative sine x. So g prime of x is cosine x plus sine x. Now we want to plug in pi over 2 for x. Cosine of pi over 2 is 0 because of the graph of cosine. Sine of pi over 2 is 1 because of the graph of sine. So this will equal 1. Alright, so that is the derivatives of the trig functions. You need to know those. Have those memorized.